So it's time that I put my money where my mouth is. I've been saying for a long time that I prefer the SCR voltage controller over the MC-2100. But you know what? I have not given this a fair test. It's time that I install this in one of my machines and truly see how it performs, especially given the fact it has a Tach input. Greetings, fellow DIYer, and welcome to my video. In one of my previous videos, I did a shootout between the MC-2100, an SCR voltage controller, and a Variac. The test was simple. I hooked each one up to my mill, set the speed at a specific rate, and then used my power feed to run work through the cutting tool. And the whole purpose of that was to see how many RPM drop we had over the course of the cut. I did that as a really rough way to determine if we have massive torque loss based on those three individual power supplies. I was quite surprised at how well this one actually worked, because when you ran the work through the cutting blade, rather than dropping RPMs, typically RPMs actually kicked up a little bit, because there are components on here that their function is to try and maintain the speed of the motor. Now, it didn't work super well because I wasn't using the Tach input. And I decided after that test, I'm like, well, maybe this power supply is better than I thought it was. And I needed to replace the crappy SCR voltage controller that was in my bandsaw. Not crappy because it's SCR, but crappy because it's the cheap SCR. And so I decided, rather than putting a good quality SCR in there, let's go ahead and put in the MC-2100. Let's hook up the Tach input and let's see what happens. To begin my bandsaw conversion to an MC-2100 to test the Tach input feature, we're at the mill. Now, why are we at the mill? Well, that's really pretty simple. The mill is providing a baseline to confirm that the Tach input is going to improve the function of the MC-2100. Because I've done testing to see if RPMs are lost on this mill with this setup, cutting 0.010 of an inch off of that piece of steel, I can hook everything up the same, add the Tach input, and compare it to the results that I got from the testing that I did on the three power supplies. Now, this is a really janky setup. I have the magnet attached to the spindle with a little piece of double-sided sticky tape, and I've got the pickup attached to the spindle with a piece of double-sided sticky tape. This is not something that I would run for long-term permanent application. This is just quick and simple install to see how this is going to perform with the MC-2100 and Tach input. As before, 0.010 depth of cut. We're going to use power feed to feed the work, and we're only going to do one test. Since I discovered in the other power supply shootout that the drop was about the same regardless of RPM, we're going to do this cut at 600 RPMs. All right, so first we're going to turn it on. I've already set the speed on it, so it should come in somewhere around 600. And now let's do the test. Other than a slight surge when we removed the load from the system, I think that's a vast improvement over the results that we saw with the MC-2100 with no Tach input. I really do think that this will work as it should and should be a fairly good option on the bandsaw. So here we have a properly assembled power supply out of treadmill components. Then we have the plugs going to my control box. I have the Tach sensor all set up. I've just got a simple piece of angle iron. It's actually angle aluminum. I once again used double-sided adhesive tape, but in this case it's a lot more firmly mounted than what I had going on the mill for the test. The sensor is firmly attached to the bottom of this, and then this is firmly attached to the body of the bandsaw. Then the magnet is right there. So magnetically it's being held in place, but I also used double-sided adhesive tape on both contact points. And what's nice about this is the magnet itself is pressing into that adhesive tape and helping increase the bond. If I was going to take this up to max RPM, that would be insufficient for two reasons. One, I would be worried about centrifugal force removing this magnet, and two, I would be worried about balance. But because I'm never going to take this past about half of its max RPM, that is totally sufficient. Now, once you get it all set up, you need to make sure that this magnet is properly triggering this switch. And it's nothing more than a simple on-off switch. So I have the Tach input unplugged in the box, and I've actually got it hooked to my meter, and my meter's on a continuity setting. And when continuity is reached, we should hear a tone. And there it is. As soon as we move away, the switch turns off and continuity is broken. And that's how this sensor works. So I know that I have everything spaced properly and that this is set to go. There are a few features of this controller that I think we should go over. I've shown in previous videos how to set the hertz. It's got to be set at 20 hertz to work with the MC-2100. So we're not going to go over that. But an important thing that we set is minimum and maximum. Because this bandsaw is being driven by a motor that even with the gearing can go twice as fast as what the bandsaw was designed to go, I need to set a max. I also found that anything less than 17%, it didn't come on at any slower speed. I could turn it down, but the speed stayed the same. So we're going to set the minimum at 17 and we're going to set the max at 42. Now I've actually already done this. If I turn this on, minimum is 17, max is 42. But how did I make that setting? It's really pretty simple. Not only does this serve as a turn switch, it's also a push button. And it's that same push button that you use to program the hertz. So if we hold it down, we get down, so we can now adjust. Let's say I wanted the minimum to be 30. We can set the minimum at 30. Or, like I need for this application, 17. Push it again, now we get the upper maximum, and I can set that at 75 or 95 or wherever I want it. In this case, we don't want to go more than 42% because that's the max RPMs that this bandsaw was originally set up to handle. So then we push the button again, and we're back to the down. So when we hold the button down, it sets. So you can see we are at 20 hertz, 41% there, 42 is the max, 17 is the minimum. Now, when I was researching how to program this, I did learn one thing that was kind of cool. If we hold it down, we get the max and min. We keep holding it. That's the lockout. That locks it so that it stays at those settings all the time. Keep holding it down. Now, did you see that point appear there? We are now at 20 hertz and we have 1,000 spaces of adjustment. So as I turn this, it's only going to go 1/10 of a percentage. Now, in the case of this particular unit, that's awesome because I'm only going between 17 and 42. And so multiplying that by a factor of 10, we've only got several hundred possible settings. If we were going from 0 to 100, we'd have 1,000, and that would be an awful lot. And my biggest complaint with the MC-2100 when I was testing was that you could not dial the speed in. But now with 1,000 options instead of 100 options, you can get it a whole lot closer. And I'm going to chalk that up to operator error. That's a function that I did not know that it had. So let's turn it on. And now I can adjust 0.1% at a time. And that's really going to allow me to dial this in. If I want to go back, let's say I only want it to go 17 to 42, 1% at a time. Again, we just hold it down. Minimum comes up, lockout comes up. And now we're back to the normal setting, the 20 hertz that we set, and we're now at 1 percentage point per turn. I still have to make my chart that shows the percentage to a specific material, and that's going to be a sticker that lives right here. So that there's no guesswork. I can just look at it and go, this percentage is steel, this percentage is aluminum, this percentage is plastic or copper or whatever I happen to be cutting. And that feature in and of itself should significantly improve the way this bandsaw works. The MC-2100 is completely installed, and this is the configuration that it's normally going to live in. However, for the purpose of this video, I'm going to move the power supply box so that you can see what I'm doing. If we turn it on, nothing happens. That is the soft start function that is part of the MC-2100. But with this board having an on-off switch, we can bypass said soft start. So we just put it off, put it back on, bandsaw turns on. And now we can adjust speed, move it up and down. We're done using it, we turn it off. Now the system is still powered up. The screen is glowing, my little light here is glowing, and that light is going to be a good thing because if I'm doing a lot of cuts, I'm going to turn it off here. If I'm just doing a single cut, I'm probably going to turn things off and on here. But I don't want to leave this whole system powered up all the time. When I'm done using the machine, I want to cut the master power. So having that light there is going to make it a little easier for me to notice when the system is on. All right, so this won't be as scientific as the mill test because I can't control the pressure that I am pushing this piece of aluminum into the blade. I can get it close, but there is going to be some human error. But it should still paint a picture. So this first test is the MC-2100 without the Tach input. And now the MC-2100 with the Tach input. So I've had the opportunity to use this a little bit, not a ton, and here's my conclusions. I've said all along that the MC-2100 was a good option, and that is still the case. Now that I know that it was operator error and you can adjust the pulse width signal generator to a finer control, I'm a little bit bigger fan of the MC-2100 as far as being able to adjust speed. I like the fact that the motor runs quiet. I like the fact that I can go slower with the MC-2100 than I can with the SCR voltage controller. I still don't like the fact that the board is fairly big and fairly cumbersome. I do not like the soft start function of the MC-2100. If I turn this on, nothing happens. And nothing's gonna happen until I power off the signal generator and power it back on. And that's kind of a pain. I'm not a fan of that piece. And that's something that you get because we are working with something designed to run a treadmill. If this was designed to run a bandsaw, it would be on off right here. You flip it on, it would just automatically go. I think for this application, this is going to be an upgrade, especially being able to set speeds based on a percent. I don't know that I would use this controller with my lathe or with my mill. Having played with it, the speed sensor definitely helps. If I'm pushing a work into the blade, I will notice a reduction in speed. There will be a drop in speed almost instantly, but then it picks back up. It goes back up to the speed that it was originally at. So yes, there's a little bit of lag, but I do like that, the fact that it does try and maintain speed. Now, part of that, again, is control. If I'm pushing a piece of work into the blade at a constant rate, it's going to be able to more accurately maintain speed. If I push it in really hard and then soft and then hard and then soft, it is still going to fluctuate. It's not a perfect system, but for this bandsaw, I think the MC-2100 was the right choice. If you like what you've seen, please click like. If you'd like to see more, please subscribe. Thanks for watching.